especially especially the flat earthers in the crowd. No.
Hollow Earth
It's
theory.
flat and it's a triangle.
I'm hollow
All the
Earth.
flat earthers all around the world.
All around the
All
It's a
around the
cube.
globe.
It's a cube.
So listen. I'm sorry I egged y'all on, but let's listen. We're talking about modeling the Earth and how we observe the Earth and try to make literal models about what we're doing. So a map is just a model of the Earth. A globe is a model of the Earth. And as technology has gotten more and more complex, we have more and more complex models of the Earth. What I went to college for is geophysics. That's how we model what's underneath the Earth's surface and try to figure out what kind of layers we have, where the oil's at, where the water's at, what plate tectonics are doing. And so you can get simple globes. You can get more complex globes. They've even started a little bit. It's not super accurate on these cheap ones like this. They've even started to give you like mountain ranges. And you can get some oceans that have like the deep parts of the ocean kind of sunken into the globe, almost like a more 3D model, which again isn't going to be extremely accurate, but it's better than just a flat surface that you have there. So they have an introduction to modeling. They talk about GPS location. So this is a global positioning systems. We put satellites in Earth. They beam signals back and forth to ground radar stations, and we're able to judge that distance by the amount of time it takes for the signal to travel from the satellite back down to the Earth. This is only a 38-second clip, and it looks like old school Bill Nye. But let's see what he's got to say about this. Hopefully he's not screaming too loud.
The use of GPS technology is expanding rapidly every day. Some cars come equipped with a talking GPS device that helps guide drivers. Handheld GPS receivers help hikers find their way. Train switchers use them to indicate a train's position, helping the crew avoid collisions. This technology has even found its way into pet collars, making it easier to find lost dogs.
Oh, that was it?
No.
I feel like they could have made it like maybe 30 seconds longer and it would have been a little bit better, but I'll just take what I can get. Take what I can get. So, huh?
It wasn't even in the video.
But his face was like.
Yeah, I guess they had him on the thumbnail at the beginning. This kayaker has a GPS attached to his kayak. He's probably just kayaking down the river, collecting samples. When I went to geology camp for my undergrad, close your Chromebook, Terry. Or don't. Come on, man. How many times I got to say it?
Once.
Or twice, and then wait for like a good 15 seconds while you just finish out what you're doing. And pull your mask above your nose. So, when I had to graduate from UTA for geology, we had to go and do like a field course for geology and go and do summer camp. And one of the things we did was go out to an area and use handheld. Everybody got a handheld GPS tracker, and you literally had to go and find different rock formations and figure out the latitude and the longitude and the elevation, and make a 3D map of the geology in that area. And so this kayaker is probably doing something similar, just with the actual water level in the river. That's going to help them not only know where the river's at exactly, but the actual water level itself, because as you get more rains or more drought, your water level is going to rise and fall, and in the river it's probably going to change quite a bit. So we move down here to GPS and cartography. We've all heard stories in history class about how the very early maps were just wrong. Like they had bad continental shapes. They had bad distances. When Christopher Columbus left Spain, he was trying to get around here to India, and didn't even know that North America and South America existed. He thought he was just going around the earth to kind of come around the other side, and he was very, very wrong about that. Even today, you can see like memes on the internet about different maps. They're not funny or great or anything, but putting a map of the earth on a flat piece of paper is always going to be wrong. You're always going to have something that's bad about it because the Earth is not flat. Like you can't find a great way to put everything on a flat thing when the Earth's not flat. And so maps like this greatly overestimate the size of things up in the northern hemisphere. Greenland is not that large. It's not even close to the size of Africa. But our maps that we use pretty often in the United States have Greenland like super enlarged and Africa really small. Africa is way larger than North America. Africa is a huge, huge continent, and Greenland is not that big at all. That's just one of the ways that this happens. If you look up an Australian map, and this is not a joke, Australian maps are literally flipped over. Australia is on the top in the center of the map, and it's upside down. Everything else is flipped. Huh? Well, it is like a meme, but it's not just a meme. It's like reality. That is their map that they use. I don't know why, but yeah, when we're done, you can open your Chromebooks and look it up. Australian maps have when we're done, they have Australia in the center, and like everything's flipped over. And to be fair, are you going to use a map with your country like relegated off to the side or split in half? No, you're going to use a map where you're like front and center, and it talks about your country the best. I think the most accurate map technically is one of the ones that has it all like split up. Like it has the wedges cut out and it's kind of folded out. That map, technically you could cut out one of those maps and glue it to a sphere or a ball, and it would be really close to a globe. And so as far as size and orientation, those are the best. But then like if the split is right here, it'll have Australia and Africa further away than it should be. And so there's parts of those that aren't even that great. Anytime you try to represent it on a flat surface, you're going to have problems. Let's see. So next page. Explore. We don't have too much to go through on these. Technology is studying the Earth's surface. Obviously, they're going to get into GPS. One of the early things they talk about is using what's called a sextant. It helps tell the location by measuring angles of stars over the horizon. And this kind of work was one of the first things we used to learn that the Earth was not flat, that it was round. And it took a lot of math to do it, but if you think about it, you can stand on different points of the Earth and see the same star. So you wait to the same point in time at night, so it's not like the Earth is rotating around you, and you travel to different places, or you could even do it at different times of day from the same place, because the Earth is kind of rotating around. But if you're standing here, the star is at a certain angle, right? If you're standing over here, the star is at a different angle, and if you're standing right in the middle, the star is right above you. If the Earth is flat and you measure precisely, if you're able to do this, which it took a while for us to be able to measure, get measurements that were super duper precise, but if you're able to measure this distance and this distance precisely and get these angles very precise all the way to the right star, you can see that the math doesn't work out when you try to recreate this triangle on paper. That is not an actual flat surface here. When you try to do the angles, they're not all going to point to the same point. They're going to point to different points in the sky. If the surface is round, that's going to help your math work out better. And so if you have this curved surface and you're far enough away where it's not like negligible, like if I go and stand on the other side of school, I'm not getting any of the curvature of the Earth. If I go from Texas to California and then over to New York, I'm going to get part of that curved surface of the Earth. And if I have the distances correct, that's going to be enough for me to see, if I get my math right with enough decimals, that's going to be enough for me to see that kind of curvature. And so now, when I do my point up here to the star from each of these, the angles are going to come out right instead of over here. I guess I should have drawn them wrong over here. But over here, what would they be? So if I'm bent out, if I do it flat, they would kind of come in over here and do that number. And that's not actually where the star is. And so using the curvature of the Earth, you get a lot better. You can also do this. I saw a video. You can also do this with shadows. If you go to a part of the earth, one side of the earth, and look at a shadow of a building and use the sun, the sun's going to cast a certain angle of your shadow. Measure how far the shadow is. You go to a different part of the earth, measure how far that shadow is, and get those angles. And you can do, it takes a little bit of math. It's all just trigonometry. It's not too bad. But you can do the math to calculate the curvature of the earth. And so you don't even have to go to space to like disprove the flat earth theory. We knew that the earth was round long before we ever got anywhere close to space. Which is why, like, obviously we know that 99.9% of flat earthers are just trolls. It's just a fun thing to do, and we get it. And that's why the smart people, not smart like smart, but smart like is in common sense. You don't engage the trolls. Don't feed the trolls. But every once in a while, there's someone out there who like literally believes, like they're not messing around. They're like, no, seriously, the earth is flat. And it's tough because there's nothing that you can tell them. Because if they're believing that, they're not going to go out and like do their own work. But it's not difficult to understand the curvature of the earth and kind of see it. Yeah.
I'm not trying to start or anything, but like, can't the earth like still be flat but still be like round?
No. Well, how's it going to be flat and
It's
round?
like it can be round but flat.
There's no inside.
No, but so if you're talking about like a coin, like a quarter, it's round but it's flat. No, because you're not gonna be standing like on the outside of that quarter though. I didn't draw a good quarter, but like an Oreo or something.
Yeah.
You're not gonna be standing on the edge. If you're standing on the edge, you'd be able to see the two edges. And the flat Earth idea. And this is why the people that are flat earthers have a really hard time like explaining how we don't know. Basically, like when you get into the real deep flat earthers that have taken the troll job like way too far, we all live here like in the center, and around the edge is like mountains.
Yeah. Like
That for some reason no one has ever crossed it. Like we can't cross mountains. Like we live in the like Stone Ages, and climbing over mountains is just too hard. We've never done it. And yeah, the government keeps us from climbing over the mountains. So like I get what you're saying. Yes, it still can be round, but if it were that kind of flat earth and you were living on the edge over here, you would be able to see the two edges. Like if the earth would be very narrow in scope. And so no, there's, and also gravity doesn't work for flat things. Like when we look out in space, none of the other planets are flat. The sun's not flat. That's not how any of it ever works. We've never seen a solar or a lunar eclipse where the moon's shadow is flat. Like the moon's shadow is always round as it goes across the earth. And it's not just because we're getting like the full size of the quarter. It's because the moon is round. Like we've been around it. And you know, even if it was, humans are terrible at keeping secrets. We can't keep, none of us can keep a secret. Nobody can keep a secret that good. Someone would tell, and it wouldn't just be like a crazy person that's like, I got it. Someone higher up would be like, you know what? The government's been lying to y'all. And they'd have proof, and it's not going to happen. I've seen the UFO videos. Like, if you haven't seen the UFO videos, the Republicans have been like releasing secret UFO tapes, and apparently the military has had more stuff dealing with UFOs than they've ever let on. I've seen them. They're not super convincing. I don't know what's on those tapes, and I don't think the people in the military know what's on those tapes. I don't think they're alien spaceships. It's weird stuff, and fighter pilots do see weird stuff, and you're in the air all the time. Huh?
You don't believe in aliens?
I believe that there might be aliens out there somewhere. I don't think aliens have come over here again just to be trolls, like to fly around and like be secretive and not like.
You think they would try to land and like talk or something to communicate?
Yeah, like you're not gonna drive to California and like sit outside your cousin's house, and then like as soon as they peek through the blinds, you drive off and come back home. Like that's a long trip for absolutely nothing to do. It doesn't make any sense. The videos are weird, and there's unexplained stuff on the videos, but it's not that I can't explain the stuff. It's just it's a vague video that doesn't really give you much information. And in like one of them, the guys, like you see the object, and it's obviously a weird object. I don't know if it's the like, there's one that looks like a triangle, and it's kind of going real fast, and there's another one that looks like a Tic Tac that's spinning around.
Wait, you seen the Tic Tac one?
Yeah, I've seen the Tic Tac.
Have you
Have you
watched
seen the
the-
Tic Tac one?
I watched Joe Rogan.
I saw.
Oh, all right. I know he's talked about them. But in one of them, the pilots talk about they literally say there's hundreds of these things or thousands of these things. Like, where are they coming from? You don't see any of the other things in the air, and it like, why is there not video of the other stuff? Are these the only people flying anywhere near this area? And on top of that, like, there's weird drone stuff going on now, and other countries, like, more than aliens trolling us, I totally believe that China or Russia would try to troll our military by sending up weird drones and making them look like aliens.
Wait, what if the government and aliens have like a pact?
No,
Which government? And why would they have a pact with
the
them?
U.S. government.
Why would they control the government?
Yeah, we struggle with a lot of things for having alien technology that we're trying to keep secret.
Like the United Nations made a pact with the aliens.
But like, so also, if you haven't heard about it, there's somebody who's flying like a drone near an airport, I think in California, like 3 or 4 times now. They've seen a human flying a drone at a height, not a drone, like they have a jetpack or something. And you've seen the jetpacks. The jetpacks exist. We're working on that technology. It's getting better. But they're like flying a jetpack at like cruising altitude for an airplane. Way higher than any jetpack can go as far as we know right now. So pilots keep seeing this human like way high up in the air with a jetpack, and they're trying to figure out who's doing it. And the idea is it's just a dummy. Like someone is strapping a dummy that's lighter than an actual human being to the jetpack and putting it up just to like troll pilots. And so I don't know. If you want to watch the videos, watch them later. Close. Yeah, we're getting better at technology stuff, and things are going to get trickier to prove or disprove. But I'm a non-believer, but I would encourage you all to go watch the alien videos because they are real videos from our real military, recorded from cockpits of planes.
I wish they would just come out and just tell us the truth. Like,
The thing is, they don't know though. They have the exact same video we have, and a confused pilot. They have no idea what it is any more than the people that watch the video.
what's in Area 51?
We really should have stormed here.
Area 51 is probably just like top secret. We have all sorts of top secret military stuff we're not telling people. I don't think it's alien stuff.
They should not do it.
Now, they could like have stuff in there that they have no idea what it is. And there could be some weird stuff in there, but again, maybe everybody who's ever been in Area 51 is super good at keeping secrets. In my experience, that's not what humans do. We don't keep secrets now.
Don't they make them like live there or something?
But you don't live there your whole life, like till you're 90. Yeah, but people retire, they get out of the military. They like, why would you not write a book and like make money off your book or sell your secrets to somebody? Huh?
Don't they watch you for like the rest of your life?
Yeah, they do. But if you write a book and then they make you disappear, that's going to prove to everybody that you were telling the truth. With who?
I don't know if that has happened.
It's a probably did. If it did happen, I think it probably, just like the alien videos that be in the news. I'm not trying to get all conspiracy theories. Yes.
There's been stories of like deathbed confessions.
Of what?
There's been deathbed confessions of Area 51 workers.
What? And about the?
And so like some Area 51 workers have made deathbed confessions about what.
Yeah.
It's nothing like big, but they.
Yeah. And I'm not saying that there's not weird stuff going on there. But like, is it like Independence Day where they literally have like alien bodies in there and the balloon crash and all that? Nah, maybe it is. I'm wrong about all sorts of stuff, but I'm not on board with that yet. So let's see. So when they're trying to measure, we're getting back on track now. All right. When they're trying to measure Earth's dimensions, we use GPS to try to get the accuracy better. And that's something that's always gone on with science. We thought we knew the distance of the sun, and as we get better and better technology, we kind of bring that number in. Pi is 3.14, right? And they teach you that in early science. And then as you get older and older, that number expands because you need to be more and more accurate. So it's no longer 3.14. It goes out further to like 10 decimals. And then if you get into like college math, you better use like 10 or 20 decimals for it because there's always like more decimals to the number of pi. It just goes on forever. And so as our technology gets better and better and better, we're trying to measure the Earth more and more accurately and know all the things about the Earth. Know that it's not a perfect circle. They call it an oblate spheroid, which basically means an oblate spheroid. And almost everything in space is this way. Because it spins, when you spin something, it's going to have more centripetal force on the part that's going faster. So when you spin the Earth, the equator is going faster than the poles, right? The poles are like barely moving at all. The equator is whipping around real fast on the outside. So when you spin the Earth, it's drawing some of that matter down towards the center. And so this oblate spheroid is basically the Earth is fatter at the poles. Slightly fatter around the middle, not at the poles, at the equator. Slightly fatter around the middle, making the shape called the oblate spheroid. And so when you see that in space, all the asteroids that we've seen, they look round until we get there, and then they're kind of like this diamond top shape, kind of real fat in the middle and skinny at the tops.
How does it not spin the same like speed?
No, what do you mean? It does spin the same speed, but so like 24 hours is 24 hours, whether you're near the poles or whether you're near the equator. But the equator, to go all the way around, you have to travel this huge distance. And at the poles, you're just doing like a tiny little circle. And so, yeah, it's all the same. Well, it's technically not the same speed, but it's all the same time for going around. But you have a shorter distance to cover the further north you are.
So you said it like makes the middle of it fatter.
Yeah.
When it spins? You think like billions of years? If we're not engulfed by the sun by then, do you think it'll
Just
like
stretch
flatten
out
out?
into flat Earth? No. And it's not very much at all. Like literally, if it weren't for like digital technology, it wouldn't even be noticeable. When you get to a certain size like Earth or the bigger planets, you're talking like just a little bit. In fact, did they say? So here we go. Out of 12,756 kilometers, which is the diameter at the equator. Listen, 12,756 kilometers, but the diameter that runs from the North Pole to the South Pole is 43 kilometers less. So 43 kilometers shorter. So real quick math. 12,000. Let's see. Clear. 43 divided by, no, it'd be the other way. Clear. 12,756 divided by 43 is, well, that's not right. I should have done it the other way. 43 divided by 12,756. So this is it times 100?
7.
No, so this is like 3/1000ths of the total distance is the difference between the width here and the width there. So it's a very, very minimal difference. Like what would that be? 0.3%? Yeah. So not even 1% difference between the equator and the poles. But it is slightly, if you're using technical measurements, it's slightly different. So, I'm not on a PowerPoint here. There's a nice picture of the Earth.
Oh, yeah,
Is there anything else I want to cover real quick? No, we got one more page. It's not going to take too long. Not going to take too long. You'll be all right. Come on. All right, here we go. So yeah, then they get into maps. And actually, like when I was doing my master's, there are like hundreds of different types of way that you can change your map to change the different sizes. There's maps where all the sizes of the continents are correct, but their shapes are slightly off. There's maps where all the shapes are correct, but the sizes are slightly off. There's all sorts of ways that you can do different maps, and they have different things for it. We're not going to watch this today. Maybe Monday, real quick. Creating and interpreting maps. what they're going to get into here, and I don't know, I might try to find an assignment for this. Did they talk about that? Navigation? A topographic map is probably the most common type of map. Obviously, this is going to be more geographic. It shows the different states, the different countries, and we use these for like political purposes. Topographic map is going to show you the topography, which is the height, like the altitude above sea level or below sea level. And so we have quite a few of those, and those are actually pretty good for hiking or for doing different kind of construction stuff. I thought I talked about topographic maps here, but oh, there it is. Some maps called topographic maps contain information about height or sea level. Because the Earth is a three-dimensional spheroid, which is a nice term to say, representing its surface in 2 dimensions on a map results in some distortion. There's always something wrong with any kind of flat map. It doesn't really matter which one you use. They talk about creating maps. They have a sample problem. Let's see what they say. So, looking at the topographic map of Emerald Bay State Park, what is the change in elevation on the hike from the water to Eagle Point? Knowing this information would give hikers an idea how steep the hike will be and what equipment they might need. Has anybody ever been hiking like on a trail? That's the big thing now. They used to not have this very much. At the beginning of trailheads, often they will tell you, if you leave on this trail, it's going to be this many miles, and you're going to go up this far in elevation. And if you're not going to make it, you shouldn't even start. Like, we don't want to have to come rescue you. You're not going to make it all the way around to this. So just be aware before you get started. I thought this was going to be a map and not a video.
It's a video.
It's only 16 seconds. Let's see what it says. Satellite image of an area. Oh, that's even worse. It's a map, or it's a video of pictures. I hate videos of pictures. So that's terrible. Here we go, image. Sorry, y'all. It is.
That's the image.
Does it give me
That's
the
the
image?
image.
It still sits on the animation. Give me the image. There's the image. Let's see. I know y'all are amazed. No, come on.
It's on top of it.
There we go. Yeah, you're right. Expand.
Your board sucks.
Wow.
I know. I want one of the new ones. I'm trying to figure out.
Just break.
Why don't they give
Well,
you a
the problem is if I break it, then how many days or weeks am I going to be without a board at all? Well, you say it's fine, but I don't think it's fine. But one of my students was like, I don't know if it was last class, but they were like, do it just before Thanksgiving. And then they got a chance to get it back.
Oh,
Or
that's
help you break you. We saw
So-
something.
Hey,
I don't know.
do it for Christmas.
Maybe I'll accidentally leave it on over the weekend and maybe the bulb will burn out.
That would suck.
But anyways, this is a terrible map. I don't see the water at all. Is the water in gray? Who puts water in gray? I don't think the water's in gray.
Isn't that
These look like neighborhood streets.
It does look like that.
Yeah, that looks like neighborhood streets. And then
This look like GTA.
there's a little creek over here. I don't know where the hiking is at. This is a terrible map. And I imagine if I make it bigger, it just gets more blurry. So I do have, and we'll finish this here. Cecile gave me this one.
Oh.
Every
It's like
time
a-
I hear the word topographic, it reminds me that
3D map.
That's cool.
Yeah.
How much does that cost?
These, I don't know. I think Cecile bought it.
Like $100.
Probably more expensive than you want. Yeah, probably closer to that. Maybe a little bit less.
Is that accurate?
Yeah, it's going to be fairly accurate. Not perfect, but pretty good.
She gave that to you?
Yeah, she used to teach this class before I started, and since I started, she hasn't taught it at all. I almost said taught it.
Hang it up.
This is Knoxville.
That's a real place.
Yeah, Knoxville, Tennessee. They got Asheville.
How long have you been in Palmer?
Oh, there's Knoxville up there. The Great Smoky Mountains.
Is Clarksville on
Waynesville,
there?
Franklin.
It's north of Nashville.
I don't see Nashville or
It's Timbuktu?
Clarksville. No. Is anybody's
Frank.
Is anybody's parents like a truck driver? Truck driver? My dad was a truck driver when I was younger, and I remember he'd have like a Atlas because he was like a long haul truck driver. He had like an Atlas, which is like a book of maps. And when you got to the edge of the map, the corner would tell you what the page for the next map was. So you had to like flip pages and see like what the next map is. But atlases were always cool. Now we all got GPS and we don't need atlases anymore. If only they'd known that they would have been put out of business by technology. I don't know. So yeah, we're good now. It's not great.
Not